constructing scatterplots. Our learning targets for today are I can make a scatterplot and I can identify outliers, gaps, and clusters in a scatterplot. Looking at constructing scatterplots, Gerald's basketball team stood at various distances from the basketball goal and counted the number of baskets they were able to make in 30 seconds. The distance each person stood from the goal and the number of baskets made is shown in the table. We want to use the data in the table to make a scatterplot and then answer the questions that follow. Now, based off our scenario, we need to identify what our independent and dependent variables are. Remember, our independent variable is our x-coordinate, and our dependent variable is our y-coordinate. The table will give us ordered pairs that we can then plot in the scatter plot. Based off of our scenario, the thing that depends on our independent variable is the number of baskets made. Because my distance from the goal, my independent variable, is not changing, where the number of baskets made is changing. So in our table, the distance is our x-coordinate, and the number of baskets made is our y-coordinate. So in our scatter plot, I'm going to label the x-axis with distance made. Now, because my actual coordinate plane isn't enough coordinates, I'm going to count each box by 2's. So when I labeled, notice I labeled every 2 boxes 4 because I'm skipping a box just so I have room. So every box is 2. So I have 2, 4, 6, 8, 10, 12, etc. And then on my y-axis, I would label this the number of baskets made. I do have enough room here, so I'm just going to count by 1's. But again, I'm skipping a box and labeling every other box with 2. So 2, 4, 6, 8, 10, 12, 14. Now I'm going to just plot my coordinate points into my graph to create my scatter plot. So the first coordinate I would have would be 14, 4. So I would go to 14, I would go to 4, and I would plot my point. Plotting the rest of my points, my scatter plot will look like this. So here's my finished scatter plot with all of my points. Now we can answer our questions. So what type of association do you see in the scatter plot, and list any other observations in the space below? So I can see that it's going in a downward trend. So this looks like a negative association. Now there's 2 other things that I kind of notice in my scatter plot. This point here is what we call an outlier. It doesn't follow the overall trend of my data. Most people who were 12 to 16 feet from the basket belong in this category. So this person made less shots than all the other people from the same distance. So that's an outlier. And then notice here, we have this huge gap. There's missing data from this set. We didn't have anyone shoot from this range of distance from baskets, so we don't know how many they made. So this is what we call a gap. And then our overall data is based off of 2 clusters. So people shot essentially from the same distances and made essentially the same amount of shots. These are called clusters. So our 3 things that we can kind of observe are clusters, gaps, and outliers. Looking at question 2, use the scatter plot to label each statement as true or false. As the distance from the goal increases, the number of baskets made decreases. So as my distance from the basket is increasing, so as I'm going to the right on my x-axis, my y-axis should be going down, which is true. This is a negative association. As one increases, the other decreases. As the distance from the goal decreases, the number of baskets made increases. So as I go to the left on my x-axis, my y-axis should be going up. Again, this is true because it's again a negative correlation. As one thing increases, the other thing decreases. This is true. And then C, as the distance from the goal decreases, the number of baskets made decreases. So as I get closer to the basket, I should make less shots, which is false. This would be a positive correlation, and I don't have a positive correlation, I have a negative correlation. Now looking at our 3 definitions of the observations that we made from our previous scatter plot. The first, looking at outliers, a point that does not fit the overall pattern or trend of a scatter plot is known as an outlier. Looking back at our previous scatter plot, the outlier in this graph was this point down here, which was Jared. This point is an outlier because if we shoot from 14 feet, we would expect to be in this cluster. making about 11 to 14 baskets. Jared only made 4, meaning he does not fit the overall trend of our data, and he is an outlier. Then looking at clustering, clustering occurs in a scatterplot when there are distinct or separate groups of points. So remember, we said that these two groups were clusters. People who shot from about 12 to 16 feet should make about 11 to 14 baskets, and people who shot from about 24 to 28 feet should make about 5 to 8 baskets. And then our last definition is gaps. So gaps were a missing area in a scatter plot. So this might be data that we just don't have or data that was not collected. So this was a gap. People did not really shoot from about 17 to 24 feet. Looking at number 2, the population of 10 cities and the number of elementary schools it has is shown in the table. Make a scatter plot of the data. So we can see from our table that we have a bunch of cities, their populations, and the number of elementary schools. Again, we want to identify our x and y coordinates. Our x, or independent variable, is going to be the population size because the number of elementary schools is going to depend on the population size. So my x-axis, I'm going to label the population. I'm going to count each box by 10,000. And then my y-axis, I'm going to call the number of elementary schools, and I'm going to label each box by 2. So each coordinate, population would be x, and number of elementary schools would be y. Looking at my first coordinate, Lawton, I have 76,000 for the population and 19 for the number of elementary schools. So in between 70 and 90 would be 80. So 76 would be a little bit to the left of 80. I'm going to be as accurate as possible, but I understand that I'm not going to be exactly at 76,000. That's okay. The only way we'll be exact is if we were to create this using a computer program, or if we had enough boxes, which in the majority of our scenarios we will not. So I'm going to do the best estimate that I can for 76,000, and then 19 would be up here in between 20 and 18. So I'm going to say Lawton is right here. Now plotting all my other points, my scatter plot would look like this. So once all my coordinate points are plotted, this is what my scatter plot looks like. Now looking at our questions, we have question 4, describe any association between the variables. What conclusions can we make? Now looking at our scatter plots data, we can see that as our population increases, our number of elementary schools increase, making this a positive association. This tells us that the bigger the population a city is, the more elementary schools a city should have. 5, are there any outliers in the data? This point right here, which is Glen Falls, is an outlier. Now, Glen Falls is an outlier because, based off of our data, cities that have populations of about 10 to 30,000 should be in this area right here, which is anywhere from 7 to 12 elementary schools. Glen Falls having a population of 20,000 and having 20 elementary schools is a weird piece of data. They shouldn't have that many amount of elementary schools based off of their population, so they are an outlier. And then 6, is there any clustering in the data? We would say no, because there's no specific big groups of data grouped together. So no, there is no clustering. In today's lesson we learned, we construct scatter plots by plotting our data as ordered pairs. Outliers are pieces of data that don't fit the overall trend of our data. Clustering occurs when there are distinct or separate groups of points, and gaps are areas of data that are not present in our scatter plot. That's a wrap on today's video. We'll see you in the next one.